Hello, nama saya Luis dan dari DEE5A. My name is Carlos Belaja Anwali. I'm from DEE5A. Hello, my name is Kenivia Elias Benderin. I'm from DEE5A. Hello, my name is Patrick Alasuri. I'm from DEE5A.
Hello, my name is Thompson Will. I'm from DEE5A.
Type of hydroelectric plant. There are three types of hydroelectric plant, which is low head, medium head, and high head. Low head. Low head application use tidal flow or river with head of 20 meters or less to produce energy. It no need to dam or retain water to create hydroelectric head. Using drop in river or tidal flow to create electricity. Medium head. Generally have head differences between 10 and 100 meters. Significant volume of water flowing and drop in head of water. The penstock in medium head slightly shorter than a high head, them as there less of an elevation drop. Lastly, a high head. High head are 10 meter or higher, which are considered as high head. System need a smaller volume of water produced. It requires a small turbine since less water flowing.
Type of turbine used in hydroelectric plant. Number 1. Francis turbine. Francis turbine is an inward flow reaction turbine that combines radial and axial flow concept. It operates in a water heat from 130 to 2000 feet and primarily used for electrical power production. The power output are generally range from just a few kilowatt up to 800 megawatt. The speed strength of the turbine is from 75 to 1000 rpm. Number 2. Fixed pitch propeller turbine. Fixed pitch propeller turbine is a propeller whose pitch angle cannot be changed. Offering considerable cost saving in terms of downtime, maintenance, and repair. Number 3. Turbo turbine. Turbo turbine is an impulse water turbine designed for medium heat applications. The operational turbo turbine achieves efficiencies of about 87%. In lab and factory, turbo turbine perform with efficiencies up to 90%. Turbo turbine can work with net between 15 to 300 meters. Number 4. Pelton turbine. Pelton turbine is a tangential flow impulse turbine in which the pressure energy of water is converted into kinetic energy to form high-speed water jet and discharge strike the wheel tangentially to make it rotate. It called a piston wheel. Pelton will extract energy from the impulse of moving water as opposed to water that wait like the traditional overshoot water will. Kaplan turbine. Kaplan turbine is a popular type water turbine which has adjustable blades. It was an evolution of the Francis turbine. Its invention allowed efficient power production in low heat application, which was not possible with Francis turbine. The heat ranged from 10 to 70 meters. The output ranged from 5 to 200 megawatt. Runner diameter are between 2 and 11 meters. Number 6. Cross-flow turbine. Unlike most turbines, which has axial and radial flow, in a cross-flow turbine, the water passes through the turbine transversely or across the turbine blade. The subdivided wheels are usually with volumes in ratio of 1:2. The subdivided regulating unit. The guide vent system in the turbine upstream section provide flexible operation with 33, 66 or 100% output and depending on the flow.
Generator frequency and voltage control principles. Hydropower plants maintain frequency control because of variable flow of water. Along with the turbine, there is generally a hydraulic control unit that opens and closes a water valve to allow less or more water in, depending on how out of phase the produced water is versus the grid's frequency. Environmental consideration for a hydroelectric plant. Hydropower does not pollute the water or the air. However, hydropower facilities can have large environmental impact by changing the environment and affecting land use, home, and natural habitats in the dam area. Most hydroelectric power plants have a dam and a reservoir. This structure may obstruct fish migration and affect their population. Operating a hydroelectric power plant may also change the water temperature and the river flows. This change may harm native plants and animals in the river and on land. Reservoirs may cover people's homes, important natural areas, agricultural areas, and archaeological sites. So, building dams can require recollecting people. Methane, a strong greenhouse gas, may also form in some reservoirs and be emitted to the atmosphere.
Apply generator operation with speed and voltage regulation. In hydroelectric power plants, the speed of the generating unit must remain constant to keep it synchronized with the grid. Usually, hydro turbines are optimized for an operating point defined by speed, head, and discharge. At fixed speed operation, only limited deviation of head and discharge are allowed. In variable speed turbines, the allowable range of variation of hydraulic magnitude is enlarged, giving rise to significant advantage in plant operation. Voltage regulation. Voltage regulation is the ratio of voltage drop for no load to the full load to the no load voltage. Full load means the point at which the transformer is operating at maximum permissible secondary current. And the no-load voltage is the terminal voltage when zero current is drawn from the supply, that is the open circuit terminal voltage. Voltage regulation describes the ability of a system to provide near constant voltage over a wide range of load conditions. The voltage regulation is normally used in case of alternator and power system calculation.
Apply generator speed and voltage regulator with drop. Generator speed. Drop speed driving a synchronous general connected to an electrical grid. This will make generator run in parallel. Load share among generator in proportion the power rating. Voltage regulator. Voltage regulator makes intentional loss in output voltage from a device as it drives as a load. It increases the headroom for load transient.
Apply generator synchronization using synchro check relay. The synchro check relay is a voltage measuring designed to be used when two power systems are to be connected together to check the differences in amplitude, frequency, and phase between the two measured voltage, taking into account deadline and bus bar condition. There are three modes of operation. The first one is live bus and deadline. The second one is live bus and lifeline. The third one is dead bus and the lifeline. Synchro check relay can be used for two functions, and the function is the synchro check function and the voltage check function. The synchro check function is allow circuit breaker closing only if the voltage on both sides of the circuit breaker fulfill the preset condition as to magnitude, phase, and frequency differences. And the voltage check function is to check the energizing direction. The main application of this synchro check relay are to connecting a generator to a system. Second one is to establishing the connection between two parts of the system. The third one is manual closing the circuit breaker. And the fourth one is automatic reclosing of a breaker after a relay trip.
Apply hydroelectric in electricity generation. Hydropower plant capture the energy of falling water to generate electricity. A turbine converts the kinetic energy of falling water into mechanical energy. Then, a generator converts the mechanical energy from turbine into electrical energy. Part of hydroelectric plant. First, dam raise the water level of river to create the falling water. Also control flow of the water. Number 2, turbine. The force of falling water push against the turbine's blade cause the turbine to spin. A water turbine is much like windmill, except the energy is provided by falling water instead of wind. The turbine converts the kinetic energy of falling water into mechanical energy. Number 3. Connect to turbine by shaft and possibility gear, so when the turbine spin it cause generator to spin also. Convert the mechanical energy from the turbine into electric energy. Generator in hydropower plant work like the generator of other type of power plant. Transmission line conduct electricity from hydropower plant to home and business. How much electricity can hydroelectric make? How far the waterfall? The farther the waterfall, the more power it has. Generally, the distance that waterfall depends on the size of dam. The higher the dam, the farther the waterfall and the more power it has. Scientists will say the power of falling water is directly proportional to the distance it falls. In other words, water falling twice as far has twice as much energy. Number 2. Amount of water falling. More water falling through the turbine will produce more power. The amount of water available depends on the amount of the water falling down the river. Bigger rivers have more flowing water and can produce more energy. Power is also directly proportional to river flow. A river with twice the amount of flowing water as another river can produce twice as much energy. Can I figure out how much energy a dam in area can make? Let's say there is a small dam in your area that is not used to produce electricity. Maybe the dam is used to provide water to irrigate farmland, or maybe it was built to make a lake of recreation. As we explained above, we can need to know two things. First, how far the water falls. From talking to the person who operates the dam, we learned that the dam is 10 feet high, so the waterfall is 10 feet. Amount of water flowing in the river. Contact USA Geological Survey. The agent is in the USA that measures river flow, that learned that average amount of water flowing in our river is 500 cubic feet per second. The formula is power equal to height of dam times river flow time efficient divided by 11.8.